My name is Daniel Wallace, and I work for Autodesk now. I've previously worked for Rackspace and SaltStack. A lot of the content of this kind of idea from this talk comes from the work I did at SaltStack. The goals for this talk is to have a better idea of how the import statement works inside of Python. For y'all to be able to describe how to augment the import structure in Python, and to provide a framework for junior developers to get into an environment and start writing code sooner. And in that vein, the goal is for a junior developer to come in and write a class like this and have it loaded into an API framework where it works. To start from the beginning, what is importlib? Inside of Python, we have the import statement. We used to have more statements. Some of them have been removed. The print statement no longer exists. It's now the print function. But the import statement's exposed to us inside of the standard library from importlib. A couple of the basic functions inside of importlib are the dunder import statement, which is just a reference implementation of the built-in import function statement. Basically all it does is it imports modules and puts them into the module cache at sys.modules. That one really shouldn't be used. It exposes more than you actually need. If you want to import something programmatically, the simplest way is to just use the import module function inside of importlib. There will be an example later in this talk about how to do that. Other useful things in the library are the reload function. Reload used to be an built-in function. It's now part of importlib. And then one that we're going to use pretty heavily in this talk is module from spec. Basically, what module from spec does is it takes a module specification. This is a word that I'm going to refer to several times in this talk. A spec is a specification for a module's import system related state. It includes stuff like the name of the module, the loader that is used to load that module, either from source file or from another location, the origin, which in this case is the dunder file object or attribute, and then the submodule search locations, which are, when it's a package, what other locations should you be able to look in to find modules, and then if it is a module inside of a package, the parent package. There's a reference implementation of this inside of importlib machinery called module spec. It's there. Okay, great. Who has used or looked at sys.path inside of Python? So above sys.path, there's a sys.metapath. The first thing that's used when you do import whatever is it goes through the Metapath finders, which are basically it's a set of three, by default it's a set of three finders that are supposed to be able to look on your system and find a spec for a module that they can then be loaded. One of them is the built-ins Metapath finder. Built-in modules are modules that are inside of the Python binary, and there's a set number of them, and that module or that finder knows how to find and load them. Then there's frozen modules. There's the frozen module finder, which is frozen modules are modules that are frozen in a state where they have their own interpreter attached to them so that they can be run independently. And then the main one to find source files on your system is the path entry finder, which is when you start importing stuff and you start messing with sys.path, that is all the locations that the path entry finder looks for modules. The main function on the Metapath finder is a find spec, where you will specify a full name of a module you're looking for, the path that we should look in, and then target. If someone knows what target is, talk to me afterwards, because I haven't been able to actually find good documentation on what it does. But the full name is the full name of the module that you want to be importing. Path is the value of dunder path, which is where to look for a top level module. And then, yeah, I don't know what target is. So that third type of Metapath finders, path entry finders. You can have a whole set of those that are for looking for different places on your file system for files. While they're both called finders, they are different types of finders. And the only thing that they share is that they find specs. A path entry finder is instantiated with a path that it should look in, and therefore the find spec does not have a path variable that you can pass to it. You just pass the full name of the module you're looking for, and if it finds a module with that spec, it returns it. Or finds a spec for that module, it will return that spec. There are two reference implementations or abstract finder classes inside of importlib, one for creating your own Metapath finder and one for creating a path entry finder. You can write your own and then put it into those list objects, and you can modify the way that you want to. You can basically if you inject it at the beginning of the list, your Metapath finder or path entry finder can be used before the provided system ones. What those finders do, once they find a spec, on the spec object is a loader. The loader is used to create a module object. There's two functions on loaders that are used for the most part. It's create module and exec module. Most loaders don't have a create module. If the create module just returns none, then importlib utils module from spec is used to convert the spec into a module. And then when you exec that module, which is the next function that's on a loader, it converts that module. The module is executed in its own namespace, and then it's an object that's actually able to be used, and you can use the functions, classes, and attributes inside of that module. There's inside of the importlib machinery, there's some reference loaders that are there. The two that I'm using for this talk are the file loader and the source loader. The file loader gives concrete implementations of the get data function and the get file name function, which are needed to load the source code or load your text from disk in order to actually create the module objects inside of Python. And the source loader needs those two functions specified in order to generate the module objects once they're executed. This is a simplified version of what that kind of second half looks like. So we're creating a file finder. This is a path entry finder. We give it a path, and we specify what kind of loader we're looking for. And if the file that we find has a suffix that is inside of the suffixes on the loader details, then this loader will be attached to it. So we use our finder object. We find spec for the OS module. Can y'all see this? Okay. So we find a spec. Then we check and see if the loader is not none, and if it's not none, does it have a create module object? If it does, we execute the create module function. If it does, we execute the create module function on the spec, and that will create the kind of module object that then needs to be executed to load it fully. If it doesn't have a create module function, or the create module function returns none, then we just assign it. We just convert it to the module type. The next function is init module adders. This is internal to the import statement, and it's basically, this right here is basically just an implementation of importlib module from spec, where this is internal to the importlib utils. This just sets the attributes on the module object, the dunder file, the dunder path, dunder name, those attributes. Once that's done, we check and make sure, is spec.loader, is it still none? If it is, or we check if it is none. If it's none, then it could be a namespace package, at which point who knows what a namespace package is? A namespace package is added in Python 3. It's basically just a package that doesn't have a dunder init file in it. So what it would specify is it would specify directories underneath it that are passed to search for to find other packages or modules. But it's not a module in itself. It's just a namespace. If it does not have a submodule search location, then it is an unsupported type and an import error is raised. If it has a loader and it has exec module on it, or it doesn't have exec module on it, we use load module. Load module is deprecated. Exec module is the one that should be used now, in which case we add the module to the system modules cache, and then we exec it. And if we get an exception, then we delete it from the modules cache. Okay, let's go to examples. So the first example, as I mentioned in the beginning, if you just want to import a module programmatically, you don't want to deal with any of the other stuff, just use importlib import module. It's really easy. If you just walk the file tree, you can just import anything that you want, and you don't have to do any of the rest of this. If you want to check if a module is importable, you can check if it's in sys.modules first. If it's not, just use importlib's find spec and see if it's there. And if it is, then you can try to convert it to a module and import it. If it doesn't find a spec, then it's not importable. There's also, you can directly import a module from file by using the spec from file location. Again, it's similar to the import module function inside of importlib. You just walk your file tree and import every file into a spec, convert the spec to a module, and then execute the module and load it onto the system. And then this will be in my, this is in my slides that can be found online, but it's just from the Python docs, it's an approximation of the importlib import module function. So that is the bulk of the stuff that you have to know in order to understand what's on the next page. The next page is this kind of idea that you can take all of the stuff that sets up your application and remove that from people that are just writing, I just want to write functions and have those functions return JSON, and that JSON can go out to users. So in Flask, you have to create an application, and then you register handlers on that application to handle different URIs. What this does is it uses a file finder to find modules inside of a specified directory, imports them, and then creates a blueprint and adds that blueprint onto the Flask application without anybody having to do anything else. So we, in our create app, we create a Flask application, and then we define our loader details. We want to use our special loader, and we want to look for anything that has, or we want to add that loader to anything that has a .py extension. Then we'll have our directory of handlers. This is a dunder init file inside of an app directory, and then inside of that directory is also a handlers directory. All of our handlers are in files inside of that handlers directory, and they're all classes. So we instantiate our finder, we give it a path, we give it the details, and then we can iterate over the handler directory. Since we're in the init.py file, we don't want to load it. But for everything else, we want to find a spec. Just look and see if we can find a spec of that module name. Oh, no, that went backwards. And then once we find a spec for that module name, we check and see if it has a loader, because in Python 3 we have the PyCache directory, and this will also find that, but it won't assign a loader to it because it doesn't match any of the suffixes in our loader details. From there, we can convert the spec to a module, and then we can execute it, and whatever this execute module returns, we can register it as a blueprint on the Flask app, and then return our app. So inside of our execute module function, we have go ahead and execute the module so it loads from source into the namespace. And then we're going to check and see if it has a version dunder or dunder version to say this is default to version 1, but if in that file we say, oh, this is version 2 of the file handlers, all these go in this file. You can specify a dunder version on the file and then iterate that so that your application can add more versions of the API. Then we're going to instantiate a blueprint for that module. A blueprint object in Flask basically allows you to lazily register handlers on a separate application and then register all of them at once on the main application. Then we're going to, because I want it to go ahead and just return JSON prettified, I'm going to use the RESTful plugin for Flask. And then we're going to take our module and we're going to look for everything that is a class and has a URI specified on it. This can be documented in your use docs so that when someone comes in, they can go, okay, all I have to do is I have to write a class that has a URI attribute on it, and it's a class. And then when the Flask application started, my handler is loaded onto the application. From there, we're going to create a resource, which is just this function up here, which returns a Flask RESTful resource object of the class, and then it registers it with our set API, the version, and then the URI that is specified for that handler. And then it'll return, once it's iterated over all the class objects inside of that module, it will return that application, which then gets registered on the Flask app and returned. So we can take this, actually I think I have them already. Yeah. So I could make an app directory. My init.py file will be this one. No, that one, this one. And then I can, once I have my handlers directory, I can just make a ping.py file that has my simple and then localhost 5000 API v1 ping, and there's my response. And then just to demonstrate that I can move it or just change the version and specify and that handler is no longer there anymore. It's now at version 3. Okay, so that's one version of a plugin system that you can write using importlib and the different stuff that's exposed to us inside of importlib. There's a couple other ones, or to kind of like iterate on that. Let's say that you write your main Flask application loader and provide it as a Python package that's kind of every single application uses that same loader system. You can use something like entry points inside of setup tools to specify, I want to iterate over all of the loaders for this and check for directories. And then once they're there, I can convert my, whatever the entry point is and find the file that it's in, or the directory. and then continue on with the rest of what's going on inside of the previous example. So then I can say this server is going to serve up these endpoints inside of my application. You can just pip install the framework and then pip install whatever packages have the handlers that you want inside of them. Another version of loading entry points is there's OpenStack manages a project called Steve Door, which allows you to load stuff from entry points as well. And then just, if you're interested in more importlib stuff, SaltStack and Ansible are configuration management platforms that both use importlib. And SaltStack has recently open sourced their enterprise plugin loader, and they call it POP. And it basically takes importlib, and instead of just putting stuff on the Flask app or a Celery app or something, the app singleton, you get a hub that allows you, gets passed to every single function call. So every function that's in the plugin system is able to call every other function that's in the plugin system. Okay, that's all I had. Are there any questions? Yeah?
So this one's a bit philosophical, but I once saw a test that imported an entire directory of modules and then tried to test certain things about it. And one day the directory was empty and it passed. It passed because, hey, every module in this directory passed this test. And I'm sure the person felt so clever writing that test when they did, but now like it passed, and then things broke in production. All that to say, like, it's great that we can do this, but do you think, what do you think are the right places to use this?
So the reasons that I've used it are to make it so that it's simple for people to get into a system and start contributing to it. That's why we used a loader system, like plugin system inside of Salt, was so that everything would just be one function, and then you can just start tying functions together to do other work. That's one thing that I think it's really good at. This one's, I don't know how to answer the question. I enjoy doing it because it makes it easier for me to document how we're writing our API handlers, and it allows someone to come in and contribute faster. There are downsides. It is more complicated on the loading portion, that you have to really make sure that someone's paying attention to that and is actually making sure that it continues to work. Those are good reasons.
Okay. So apologies, I just have a couple of quick comments. One is that Target essentially is just a hook for third-party loaders.
Awesome.
It's sort of, think of it as try to find this thing relative to this module that I'm going to pass in. I don't believe it's actually used in the standard library at all.
Okay.
The other thing is, especially for like entry points, you might want to take a look at importlib resources and importlib metadata. Those are two resources came with Python 3.7. Metadata is coming with 3.8, and they're built on the import system.
Okay.
And they're a lot more efficient than package resources. So like,
yes,
package
resources is very slow.
Yeah, stop using package resources, everyone.
Great.
Any other questions? All right. Oh, one more.
So when you're using entry points, preferably with importlib metadata as opposed to package resources, it looks like you're using the entry point to find a directory and then continuing to just use your loader.
Yeah.
What's the advantage of that over just using entry points to import the module directly?
Right, yeah, so you can load the module directory, but then you have to specify it for every single module that's in the directory. There's not a reason to not use the entry points, but to just load all those modules, it would be personal preference.
Okay, thanks.
So yeah, you would have to specify, if you wanted to do it for multiple modules or multiple modules inside of a package. Yeah, it would just have to be specified once per module you wanted to include.
All right. Thank you, Daniel.
Yeah.